Hi, I'm Bharat from Nexion. I'm gonna do a training for BMS systems for the project Baldwin Elizabeth Baldwin Elementary School. Yes, sir. So, so, so this is the home screen basically. So we try to do some 3D graphics on this one. So, so this is the home screen basically. So anywhere on the title, if you hit anywhere you go, any graphics you page you're on, when you hit the title button, you'll be back to this home page so that you can navigate to different systems. So basically, like we have the RTUs, VAV, the hot water system, the radiance, the unit heaters, exhaust fan, and the integration and the floor layout. Basically, so I've segregated into these are all the main option buttons for me. So let's go to the RTU summary. So basically, we have like 8 RTUs. So I gave the summary, which, of course, the summary gives like most important points that they can see. So from here, I have linked that to an individual 3D summary page for each RTU. So from here also, you can navigate to all the RTUs as well. So uh, basically, right now, the RTUs are RTU1, RTU1 to RTU5. So they have VAVs. So they are basically running, yeah, RTU1 to 5. So they are maintaining the discharge air temperature. So that is reset based on the outside air temperature. And so we have the warm up mode and we have the cool down mode. And this warm up cool down mode can happen in unoccupied sequence as well. And also the cool.
So you got daytime warming happening from the unit itself also,
Yes.
not just morning warm up. So okay, in the morning the unit time schedule comes on, does morning warm up, gets to a set point, right?
Yes.
After that, the VEVs take over.
VAVs take over. Yes.
During the day, if we need more heat from the unit will start up. Gas burns will start up and give us heat if needed.
Exactly. So the morning warm up is decided by the optimizer. So based on it will calculate the outside air temperature, and based on the outside air temperature, it decides whether you need a morning warm up for that particular day or not. Probably it may skip on that day. Probably the load is not there, but let's say during the occupied time after the VIV has taken over, but the average space temperature, let's say it is like way below 68 or way, right, you can adjust that set point, right? And it is, and your radiant panels are your first stage of heating. But if your radiant panels couldn't keep up the heat, then the morning warm up is going to kick in as a second stage heat. So let's say the morning warm up has already taken place in the morning, like uh, based on the calculation of the optimizer block, then it's not going to come because it's going to come only one time.
Okay.
Right. So, but let's say it is skipped, but during the occupied time, the space temperature dropped down and your radiant panel couldn't achieve that first stage heat, then the morning warm up kicks in. Same thing applies to cool down as well. Let's say during the course of a time, like your temperature is more than 76 degree, that is adjustable. So it is all space averaged. All the VAV temperatures are averaged. So you have a space average temperature. Let's say that could not maintain like 76 in the space. let's say that is the set point you keep for the cool down, then it's gonna do the cool down during the occupied time as well, not only in the unoccupied time. Okay. So, and yeah, during your cool down, basically, if there is an economizer option that is available, that economizer is gonna override the cool down. If it is available, if the enthalpy is met, and then it's gonna override the cool down. So basically, yes, like cool down mode and warm up mode, so two modes, and then the outside air damper is gonna track. No, sorry, the exhaust fan is gonna track the outside air airflow. So basically, we are measuring the outside air airflow, and also we are measuring the exhaust airflow, and we are measuring the supply airflow. So the exhaust fan is gonna track the supply. Sorry, the outside air. So that is the other sequence. Yeah.
So the ERV is 100% makeup air, or we're closing the louvers off to minimum percentage.
Yes, it is not 100% makeup.
So okay, so we're not 100% fresh air all the time.
No. Yes, that's right.
Okay. Our CO2 levels go up higher. Does the VFD on the unit take more air from outside to bring down the CO2 levels in the classrooms?
Yes. So we have a CO2 control as well. So that is based on the space again. Like we are averaging the space CO2 levels, and each VAV has like a humidity. It is integrated with humidity, CO2, and temp, right? So all the space CO2s are averaged, and if the average, so and that is adjustable. And if the average goes more than, like right now it is 800 ppm, so if it goes more than that, and it waits for, like, for example, let's say I have like 20 VAVs, right, in RTU1. So let's say what is my 10%, like 2 VAVs, right? So if 2 VAVs or 3 VAVs are like, uh, if it goes more than 800 ppm, then I'm gonna have a CO2 control on my unit. Then that's gonna make, so the VAV is going to have a local CO2 control by opening the damper, so that is what it's going to do. But so that command is going to be passed to the RTU, and that's going to start taking the control of the CO2 as well, bringing in more fresh air. So and again, that 10% is still adjustable. You can make it 20%, or you can make it, even one VAV is trying to get trying to meet a CO2 demand, then it will open the damper. So that's a CO2 control, and we talked about the warm up, and we talked about the cool down, and of course, so then the discharge air set point is based on the OA reset.
So outside air reset.
Yes,
Okay.
outside air reset, and
Also, does it take into consideration if my rooms are overheating? So let's say five rooms, 5 UAVs.
yes,
3 of them are overheating.
right.
Does it change my cooling set point automatically lower to try to cool those rooms?
So okay, so the RTU is gonna reset only the discharge as set point. So if you're saying if the 5 rooms, let's say it is overheating, right?
Let's say 3 are overheating out of the 5.
3 are overheating out of the 5. So in that case, so let's do the math. Like 20 VAVs we have, like 3 are doing, so it's not going to affect, if only 3 are overheating, it's not going to affect my space temperature. So I'm not going to bring in my cool down mode. So if let's say 6 to 7 VAVs are overheating, then by math it's going to affect my average space temperature. Then I'm going to I'm going to bring in my cool down mode if necessary.
Yeah, I was using an example of 5, so 3 was over 50%.
Okay.
You're using all 20. I get it. I understand.
Understood. So then it will put. So right now the scale is like we are still tweaking the reset range, like between like 55 to 62, but the cool down mode is going to give constant 55. Yeah, and the warm up mode is going to give constant 80. That is again adjustable.
Yeah. Okay.
Right. So, and we talked about the discharge air, and of course it's gonna control the DP. So the DP sensor, the duct pressure sensor, and what else? We have the interim and of course we have the dehum mode. So dehum mode again is based again on the average space. So if the average space humidity goes above certain range, let's say for example 60%, then I'm gonna turn on my dehum mode on my unit.
Okay. Dehumidify.
Yes. So and so yeah, if it subcools, then have then my gas heat kicks in. That is taken care by the unit itself. And what else? So and again we have the energy wheel operation as well. So the energy wheel operation is basically like based on the enthalpy, it's gonna decide okay when I have to run, and if the exhaust fan is on, I'm gonna run because I'm gonna pull air through the wheel. So there are some conditions like if my exhaust fan is on, if my economizer is on, or if my enthalpy is satisfied, then I'm gonna run the energy wheel to use the either it can be used for a cool recovery, or it also can be used for a heat recovery.
Excuse me one second. Hey, Mark. Mark. The unit was down this morning. It's right now. It'll take a little while to cool down. All right.
So yeah, so that's the energy wheel operation, and also we do some kind of a freeze protection on the wheel. So for example, if the outside air temperature is, let's say, adjustable again less than 30 degree Fahrenheit, and the pressure between my wheel goes more than 1 inch of water coulomb, then I assume it's a frost. Then I spin my wheel very slowly, so defrost it. So I have some kind of a defrost operation is also going on in the sequence. And what else?
Will we get a copy of the sequencing?
Yeah,
Okay.
yeah, we'll give the copy. um, I'll send it to you in an email. Yeah. So and the other thing is I'm trying to tweak some set points on something called a dynamic temperature band here. So what we are doing is we are trying to change the duct static set point during the course of operation. It's not static. Basically, it's a duct static set point, but we are trying to increase or decrease by proportionally based on the load on the VAV. For example, if let's say 70% of my VAVs are more than 90 percentage open, then I'm gonna, so which means most of my primary zones are satisfied, and I'm trying to decrease the static to conserve energy. Not much, like 0.2, 0.1, 0.4. I'm still figuring out that range, but
So static will be on the positive side a little bit, though, whatever. 0.1, 0.2, 0.3.
exactly.
Okay. Not on the negative side. So
Not on the negative side. Yes. And yeah, so user will be having ability to still have to do those interfaces on the VAV. So for example, let's say the average temperature probably you might see like 89, means some VAV is screwed, right? Some VAV is screwed it. There is an outlier in the average calculation. So something is screwed. So you should, from the user interface, you should be able to unselect that VAV so that it doesn't go through the dynamic DP calculation, so that you don't screw the pressure set point.
okay.
So you will have that ability in the user interface to do that. And other than that, so we talked about cooling, we talked about heat. Yeah, cooling, of course, it's compressors. So they have one modulating compressor and two stage compressors.
I'm just curious why we're not doing 100% fresh air. Majority of our buildings that came online, they're all doing 100% fresh air. Just curious.
Okay.
Engineering, just curious why. I mean, it's definitely more economic because
Yep.
you're not bringing in, you're not heating and cooling 100% fresh air.
Yeah.
Why are all of the rest of our buildings, new buildings, 100% fresh air, not this one? That's really my question.
Okay.
I'm assuming it was engineering, right? But
Yes. Yes. So the one thing I can, so for example, let's say 100% fresh air, you have VRFs.
yes.
Yeah. So we have only VAVs here. So that's the big difference, right? So uh, for example, let's talk about cooling, right? If I have a VRF system, right, whatever the air I get it, right? Whatever the air I get it, I'm gonna cool it
Yes.
because I have the system.
Capacity.
Yes,
Okay.
but let's talk about VAVs. It's not whatever I get it, I can cool it. No, the VAV can only open the damper for cooling. Right? If I open 100% outside air, right, and let's say I couldn't maintain, it is all dependent on what is incoming. I don't have any local control for cooling, right?
Yes.
So probably that could be the reason. I don't know.
Okay.
Yeah.
All right. I understand.
Yeah, because
Where you going with that? 100%.
yeah, because
Okay.
personally, I didn't see maybe like 100% units for VAVs at least. I have seen for VRFs for
Yeah,
sure,
oh,
fan
yeah.
coil
Most
units,
of our
all
middle
are
schools are all
DOYAS
VR.
units, ERV units, but for
Not for VAVs.
VAVs,
Okay.
yes.
I understand.
And what else we have, sir? So we talked about the economizer operation, so economizer and also the CO2 control, and we talked about the wheel operation, and we talked about the discharge air cooling. I think that's what we have. Other than that, the three important things we have here is the warm up mode, cool down mode, and the dynamic set point change that happens. Uh, I think that's it. And it's gonna recirculate either if it is in a cool down mode or a heat warm up mode. It's gonna recirculate 100%. There will be no outside air coming in during the cool down or warm up. Other than that, it will try to fetch the minimum outside air all the time. But based on the economizer demand or a CO2 demand, it's gonna modulate to the maximum.
Okay.
All right, so this is what, so I've made the graphics for all the units. So it's gonna look exactly the same. And yeah, you know, right? So
Yep.
yeah. So if I go to a summary and I can click the title and I go back to the RTUs and I go back to the VAV. So VAV again, you know, the pressure independent VAVs. So uh, they are like basically they don't have anything in the VAV itself for heating. So they have a radiant panels.
Okay. So there's no hot water coil in the VAVs.
Uh, there is a radiant panel just next to the VAVs,
Okay,
but
so
not like a typical
not
hot
like a
water
coil
coil
inside.
the
Okay, I
VAV.
get it.
Yeah.
Yeah. Okay.
So everything is radiant, and it is everything is on the ceiling,
Okay.
right? So that is how we are heating it. Still, it's a reheat, but it's a radiant reheat. Yeah. So and let's touch upon the operation of the VAV. So it's going to have its minimum and maximum CFM for the set airflow set point. So if it is cooling, it's going to range from minimum cooling set point to maximum cooling set point. And if it is heating, again the same minimum heating set point to maximum heating set point on the airflow. And during the during the normal, let's say if my heat set point is 68, right? And cooling set point is 72, and my space temperature is 70, which is in between. So I'll be in a vent mode. So basically, I'll be doing only the minimum CFM, right? and let's say when I'm in a heat mode, so it is gonna drive the valve open and it is gonna radiate the heat. So all these valves, like probably whatever the valves which is above 1 GPM, they are modulating. They're gonna modulate to open from 0 to 100%. And the valves are not maintaining any discharge at temperature. At the VAV, they are maintaining only the space time, right? And most of the toilets and the hallways or two position, they are not modulating. Probably they are like less than 1 GPM, and they're gonna on and off based on the space temperature. So basically that's what we have. The other interlock that we have between the RTU and the VAV is basically the warm up and the cool down mode. So when the warm up, so basically, so this is very interlocked sequence here. So my optimizer decides based on the outside air temperature. My optimizer decides, okay, whether I have to go to a cooling or go to a heating, which means, sorry, go to a warm up or go to a cool down. But it is based on what? It's based on my VAV's input, which is my space temperature, the average space temperature. Okay, I get the space temperature, average space temperature input. I calculate based on my outside weather, and I calculate based on my next schedule. Okay, then I decide, okay, I want warm up, I want cool down. Okay, now it says to my RTU, okay, you should be in warm up and you should be in cool down, right? And then RTU says my VAV, okay, we are on warm up, we are on cool down, now open all your dampers to max. So that is how the chain of communication or sequence works between the VAVs and the RTUs. And hey, James. Uh, so, and apart from that, it's same thing. Like we have the feedbacks for all the valves, and it's the same like modulate control, or like a 0 to off or on control, two position control for mostly the common areas and the toilets.
Are we going to have a diagram of the school so we can just, okay, we can see all the classrooms or X amount of classrooms at once?
Yeah. So I'm working on it. So I'm
Okay, so you'll put in,
yeah. So this is the floor one A wing layout. So you can, so this is the, we can change the legend if you want. For example, I'm like maintaining if it is below 67, I'm going sky blue.
okay,
Uh,
so we will not see the individual temperatures. We'll only see blue or red, whatever it's on, not the individual temperatures of the classroom.
we can put it if you want. We can put it if you want.
I think it'd be good just as
Yeah.
a quick
Okay.
reference in the morning. We usually check all the BMS.
Right.
So we pop on, okay,
Yeah.
everything looks good. We don't get into it any further
Right.
unless we see something.
Right.
So many calls.
Right.
So it'd probably be nice to have that.
Yeah. Okay. We'll do that. Anyhow, I'm gonna do that actually. So, um, so if you click this spot, so you're gonna get that. Also, I'm gonna put the location name here,
Yep.
and also the temperature. So if you click it, it will go directly to, it should go actually. So it will go directly to the VAV page,
Okay.
individual VAV page. But however, end of the day, you will be having that temperature and the location name.
Perfect.
Right? So and you, so we have the flow layers for all the flows. So that is A wing, this is B wing, and C, and A wing and B wing for second floor as well. Right? And the next thing, so hot water. So we are running the pumps and everything, but they are in operation. But I need to bring the points from a router. So we are just waiting for a router. So we'll be getting the hot water informations from that one. And the radiant panel. So apart from VAV, so VAV has its associated radiant heat. But apart from VAV radiant heat, we also have standalone radiant heats, like just for bathrooms, for hallways, and like common areas. So we have a standalone radiant heat where we have a blank plate sensors, and you can have the set point from here, and so that drives open the valve. So mostly the standalone radiant panels are open close type. So that is again based on the space temperature. So the other thing I forgot to mention when we talked about VAV. So you can override the occupancy. So basically you can set the schedule. So right now we are in flush mode. So it's all 24/7. So basically you can set whatever the schedule you need. But if some people coming here, let's say for an event in Saturday, Sunday, or after the working time, so that is a override button, occupancy override button on the thermostat, which you can click and put it in a bypass, which is basically occupied for 2 hours.
Okay.
So they ask for a 10% of 10% of local occupancy override. Then I will make my unit to be occupied. So for example, like I have 20. So if the two VAVs are occupied, right? So then I will put the unit to occupy.
Okay.
Based on the sequence. So as we talked about, so the radiant panel is the same thing, but it has a blank plate sensor and you have the set point from here. And the VIVs, you have the display. So we have, we can restrict based on your, like need. Either you want to give user the permission to override from the classrooms, teachers can override from, right now it is dual. They can do it and we can do it. So
Yeah, what kind of swing are we giving the teachers on the
68 to
thermostat?
74 right now.
Okay. That's
Yeah. So if we can either we can change the limits or we can restrict the permission. So so that's customizable. So and for basically for the standalone, so standalone radiant panels are just a blank plate sensor. So you need to provide the set points from here.
okay.
Yeah. And what I have is again the
The
unit.
radiant panels in the hallways, stairwells, whatever. Is that part of the schedule? Like if we have a schedule for the whole building, does it turn those to night setback also? Or do those keep running?
They have the schedule as well. So they have occupied set point. So if you see here, and they have the occupied set point and non-occupied set point.
Okay, that was my question.
Yeah. So and what else? Other than that, we have just a unit heaters. The 12 of the unit heaters only in the stairs, like the cabinet unit heaters.
Okay.
So basically,
With the hot water coil?
Yes. So basically, they are not different from radiant panels. Just they have the fan. So basically, we are trying to same the blank plate sensor, and we give the set point from here. And let's say if the temperature goes less than the set point, then we're going to open the valve. It's most all the unit heaters are on off valve, so two position either on or off, and controls the space temperature. And basically we open the valve and the aquastat senses the heat and it turns the fan on and we get the fan status. So that is all the unit heaters. Apart from that, let's talk about the schedule. You guys know that very well. And alarms. So you can access all the alarms. So these screens are in the background, so they don't disappear. So that comes in all the pages, so that you can, yeah, yes. And basically the trends. So trends you can drag and drop. So basically I have set every trend. So go to the histories and drag and drop whatever the trend you want on this page and export it in the Excel if you want. So yeah. And other than that, only the other stuff we have is the exhaust fan. Exhaust fan again is all based on occupancy.
Do we have a separate RTU for the cafeteria?
Yes, the Macapair.
Okay.
So the Macapair, what it's doing is when the kitchen hood is on, right? So that gives a signal to turn the Macapair unit, and on also based on the output from the kitchen hood controller, it drives the fan speed as well. So we only regulate the temperature on that McApair unit from the BMS side. But so life safety, so they turn on the unit and they drive the speed.
Okay.
And so we just only control the regulate the temperature in the McApair unit. So and the other stuff I forgot about VAV. Sorry, I'm going back to the VAV. So the occupancy sensor integration is in progress. So we are integrating to the lighting panel. So they give me the occupancy sensor status from each room. So based on that occupancy sensor, motion sensor status, I override my effective schedule so that so now when occupancy sensor comes into the picture in the field equipment, any terminal equipment, then the set point we have a different concept for set point now. So it's an occupied set point, unoccupied set point, right? So during my occupied schedule, if my motion sensor is detected, then only it goes to occupied.
Okay.
Right.
So what about, okay, I'm occupied in the morning, I'm going to lunch.
Right.
So occupancy system says, okay, there's nobody in the room. Does it go, what does it do?
Standby.
Okay.
So that is a standby. That is also adjustable from the graphic. So for example, let's say my occupied set point, according to the sequence they asked for, is 74 is my cooling set. But let's talk about cooling. So 74 is my cooling set point. So during occupied, when my motion is also detected, 74 I wanted to achieve. If it goes more than 74, I open my damper to cool max, right? Or modulate to cool max according to the demand. But let's say no one is in that room. Now it goes to standard mode, like a standby mode, because I think it waits for like 15 minutes or 20 minutes. So after 20 minutes, it goes for a standby mode. Now the standby cooling set point comes into picture. Probably your standby cooling set point, not 74, because 74 is an occupied set point. So I wanted to give like 2 degree more than occupied set point. Probably 76 is my cooling standard standby cooling set point. So I will try to maintain 76.
So as soon as you walk back in, it goes back into occupied mode, and it does whatever it needs to do, whether it's cooling or heat.
Yes.
To achieve this 74, whatever that set point is. Okay.
Yeah. So yeah, so I recommend having at least 1 degree above for cooling, in the sense at least 1 degree above the occupied set point, and for heating 1 degree below the occupied heating set point. But people see they do match all the time. So then there is no standby concept. Then that is irrespective of the occupancy status, it is always in occupied and occupied set points. So in that way, we don't conserve any kind of energy.
I understand.
So yeah,
I like the two degrees, like you were saying.
Yeah.
74, 76, whatever.
Yeah.
66, 68, or whatever.
Exactly.
2 degrees. I like the 2 degrees.
Yeah.
Okay.
At least in BMS industry, at least when there is an occupancy sensor like we have here, we have occupied sensor, occupied heat set point, occupied cool set point. The one good point for conserving energy is standby heat set point and standby cool set point. But let's talk about guest automation. They go one step further. There is a rented occupied heat set point, rented standard heat set point, unrented standby set point. So they go one level higher, so they conserve more energy in the hotel industry. Yeah. So yeah, so this is what we have, and we are waiting for one. So we are basically integrating. We have already integrated the lighting, and we are basically integrating the BTU and several the electric meters and stuff. So you'll be saving. I'll be having some energy dashboard as well to show you the consumption of these meters as well.
We're not controlling any lighting though through the BMS.
No, we are just getting the occupancy status.
I understand.
That lighting portion of it, that's only during the occupied hours, or that during any time? Unoccupied?
Anytime.
Anytime. So if
Anytime.
somebody comes in here at 11 o'clock at night?
Yes, good. Yeah. So what happens? So your schedule will be basically unoccupied, right? So if somebody comes late night, so what happens? Then it goes to bypass mode. So what it happens when you do a override button, right? So it is unoccupied, but someone comes during the unoccupied time and try to push that button, so it goes to bypass mode, which is basically occupied mode. So same thing happens to the occupancy sensor. So if someone tries to come during the unoccupied time, so then that goes to a bypass mode. We can change it. It can go to a standby mode, so that's customizable.
Yeah, I don't, we'll talk about it, but I don't know if we want to give them walk in and bypass anything. But
Okay.
it's gonna look for X amount anyways, right? It's not gonna start the unit till
Yes,
somebody
so-
pushes X amount of, not one individual room is gonna start the unit.
Exactly. You can configure that percentage. You can put it 100%. So the unit will never go to a occupied mode until all the VAVs under that unit goes to occupied mode.
Okay, or a percentage.
Yes.
50%, whatever.
Exactly.
Okay.
Yeah.
Understood.
Yeah. Let's say VAV1. So RTU1 and RTU2 each has 20 VAVs. RTU3 and 4 have 17. RTU5 has 12. Yeah. So any questions? So I think I covered
Right?
whatever.
Nothing? Okay.
All right.
Good.
Thank you, sir.
Nice.
Thank you.
So, yeah, I don't know if you wanted to take them to those cabinet unit heaters or any of that equipment.
Yep.
Show them where it's located.
Yep.
Show them the AV. I can see the 3D.
Sure. Yeah.
Cabinet heater down wall on the stairs here, the wide open.
Yeah.
So you should be able to get right into it.
Yep. So the radiance. No, this is a duct. I want to see this room's.
We can probably get in.
Okay.
Should be the same key, right?
Okay. So they want to see the radiant panels first.
Yeah,
So.
they should have them in the stairs.
Should be the same.
Stairs?
Yeah.
Oh, okay. Okay, any of you open the unit?
Yeah.
Thank you. So on the window side, on the classrooms, near the windows, they have these radiant panels. Yeah.
Okay, so that's a rating panel right there also?
Yeah, this is also a radiant panel.
Okay.
Yeah.
Whereabouts is the VEV? I'm assuming up here somewhere. That's it.
Yeah, it's should be. We have stickers here, so we can try to find the stickers.
Yeah, so the stickers that are yellow circles should be anything HVAC related. So they'll be on the ceiling grid itself.
Yeah, but sometimes the yeah.
Right there.
I see.
Okay.
All right, so up there is a VAV.
Yeah. And so here, this is what I was talking about. So, right, if you so this is the home page, right? So you go to more, right? You go and change your set point, right? Whatever you want, or you go back. You want to do an override, and if you do override, then it is override.
Okay.
So it will be overridden for 2 hours. So or you can cancel the override.
Okay, so what are the teachers going to be able to do here?
They can change the set point. They can do an occupancy override.
It'd be nice if they can't do anything else besides that, though. Because if somebody starts going in and change things,
Okay.
humidity settings and whatever.
Okay. So they have no access to change
Okay, 'cause
anything.
I just seen the
other-
humidity sensor come up. Okay,
Yeah,
so
that is a
everything-
value. Yeah,
Okay.
that's a reading value.
Okay, so the only thing they can do is temperature and occupy.
Yes.
Okay.
The CO2 is read only, the humidity is read only, and the only the writable points are set point and the occupancy override.
They have a, what is it, from 68 to 74 here?
Yeah,
They do?
68 to 74.
And that's gonna, they're gonna stay, do you think?
Yeah, you might as well leave 68%.
Some schools they ask like, I want to go 60. Okay.
We're not going to give them that.
Yeah.
I mean, that controls.
All right. So. Oh yeah. Sorry. Okay. I didn't know that.
This is reading.
Yeah, so they get the zone valve, sends it in and out.
And we have two methods to maintain the DP on the loop, water loop. So we also do, basically, normally we do the through the pump, we vary the speed to maintain the DP, and also we also maintain the DP if, let's say, pump is already at minimum, right? But still my DP is higher, then I try to modulate the DP or maintain the DP through my bypass valve as well. That is also controllable and modulating. Guys doing so. This is the unit heaters. So they have in all the states. So basically, so this is the sensor here, the blank plate, and so the set point is only from the BMS, and so we put our valves, probably it's in the somewhere, not here, but we open the valves and the aquastat turns the fan on.
Okay.
And we get the fan current status. So do you want to prop open any VAVs or? Okay. Then I think what else we have? We want to go to the roof.
You want to go see the unit on the roof? I mean, we're up on the roof the other day. I mean, the unit's just the same as
Yes, it was, yeah.
same
Yeah.
as the other ones.
What was the cafeteria one? The, what's it, the McAfee? What is that? Did you say it was the McAfee?
Oh, makeup air unit.
The makeup air,
Oh,
yeah.
okay, that's good.
Yeah, that's the kitchen hood unit. Yeah.
Yeah, so as it exhausts, they'll turn it on when the air.
Yeah.
To maintain that static pressure that we want.
Exactly. So that is only for the kitchen hood.
Right.
So that's only during the like I told. So whenever, so we can see the hood switch if you want.
Are you doing the second part of the training too? HVAC owner training?
I don't think so.
I don't.
No, okay. So he's just doing BMS. Okay.
We'll have someone
Probably
jump in
HVAC
the
from Jeff. Probably Jeff will be doing that. I think here.
We want to see the room where the head end is going to be.
Sure, yeah. So that's in the same room, like the IDF room. So we put a rack server. So so probably once I get the IP from the school, then if you're connected to the network, you should be able to access it from the browser. Yeah, I think
Okay.
if they turn the hood on from this display, so they have the hood panel here. So this gives the command to the McAfee unit, and it turns the unit on, and also it controls the speed of the fan.
Okay.
So this just exhaust, and that supplies. And during the life safety and they trip both.
Everything shuts down.
Yeah, but the exhaust fan turns on.
just go into the room where you're going to have the head end?
Yeah, sure.
It's not going to be downstairs. I thought it was going to be downstairs.
Oh,
Hold on.
okay.
Ryan, excuse me. Ryan. I thought the head end was supposed to be downstairs, right?
Head end room?
Yeah, where we're going to have.
MDF?
Yeah.
Yeah, it's down there.
No, so we installed the head end in that first floor MDF because there we have our switch and we have our local VLAN. So basically the IT infrastructure here is, let's say, like we have like 95 plus IP controllers, right? So the IP is the spec here. So I need to have my own VLAN, local VLAN, so that I don't want to ask 95 IPs from the school, right? So I don't want to put my controllers in building network. First of all, like again, it's like they have to create a new VLAN for us, and again, I don't want to jam the traffic with all my BMS controllers. So we create our own VLAN. So we put our switch, which is like a very, because second floor is easy to access the roof, and all these go to home run. All the loops go home run to my second floor. So I think we discussed about that, and we put the head, and so my switch is there. So we put the rack mounted server over there. So
is that where you're going to have the computer that we can log in to the system?
so we give the server itself, so anyone in that network, so basically you don't need any computer, like for example for
Okay,
a
so
BMS.
just- Okay,
So it's on the network, so you are
IP
connected to,
address, and I
yes,
can connect anywhere. But I just thought originally we were going to have something down here, the computer set up, walk in. And do it.
okay,
Yeah, we discussed final location is in the storage room right there on the radius wall on the first floor right here, for the actual computer. Has
so
that changed?
yeah, I think we had a discussion with Frank, and I think Frank had a discussion with the team.
It's just if it's inside that back room, it's a problem because that's a classroom. You can't just walk in there. Even though I can, as long as we have an IP address, I can log in from anywhere.
Yes, exactly.
I understand.
Yeah.
It's okay.
Yeah. So that's going to be in your building network. So I'm gonna get only one IP from the building. So that server is a 2 NIC. So 1 NIC is for my local, so which you don't enter or don't talk to. So that the other NIC is connected to the building. So if you connect to that NIC with that IP anywhere, either, so it's based on your in-house IT. Sometimes
I understand that 100%. Just I was under the impression we were going to have
yeah,
a setup
yeah,
in one of the rooms.
yeah.
Our setup's gonna be down here on the first floor.
All right, so
We'll
we
talk
are going to.
about- We'll talk about it later.
Okay.
Okay. So yeah, so it's based on the IT. If IT gives you Wi-Fi access, normally BMS they give only the Ethernet access, like wired access, but some school I have seen people also expose that network on the Wi-Fi, so that if you're in the building, if you're in the Wi-Fi, you can access BMS.
Yeah, we do that with all the rest of them.
Right.
Your iPad, walk around.
Yeah.
Yep.
And the graphics scales, like the graphics that I put scales mm, for 1.5% max, and also scales down to 0.75%. So if you are using iPad, so the graphics will shrink accordingly. It's resolution friendly. And if you are using so you have lots of monitors here, if you are using a big monitor, and it will scale to a big resolution as well. All right, so let's go and see the head end now.
Yep.
Before we do that, you go over, I know we talked about the kitchen. Exactly. You got, you know, where the VFD is for the exhaust fan inside the cabinet of the hood.
Yeah, I shown them the switch they use, and also I've shown them the panel inside the hood.
So the money is like sits in my account.
James. So this is our switch, so which connects all our VLAN, and this is the server, the rack mounted server. So we put this monitor for temporary purposes so that we configure it. So this will be, so it has two NIC cards. As I said, one NIC card will be for the billing network. One.
All the controls are Honeywell, right?
All the controls are Honeywell, yes. The walls are Belimo, and the sensors, the thermostats are Honeywell, basically. The black plate sensors are like probably like I think they are like Honeywell or maybe a Dwyer or something like that. But most of the majority of the controls are spec Honeywell. Like for BDO meter is Onicon, and
I mean, we're good unless you have something else. I would like to get a copy of
the sequence of operation. Yes.
Yep.
So probably what do you need? Like a sequence from our as built, or yeah, I can give
As-built.
yeah
something to that.
yeah sure
So we know that
yeah
we're looking at it. Here's the sequence.
yeah sure.
Right? Anything?
Faster.
Good.
Done.
Awesome.
Thank you.
guys.
Thank you.
Thank you, sir. Thank you, sir.